Let's say we take this first problem. You want to find a third degree polynomial that has real coefficients and zeros at 4, 3, and negative 5. So you're going to use that linear factorization theorem, that idea that each of these zeros has a corresponding factor of x minus the 0. So you know that your function is going to be in the form f of x is equal to some coefficient. We're going to calculate that in a little bit. But we know that our factors are going to be x minus the 0, 4, x minus 3, and x minus a negative 5 becomes x plus 5. And now, we don't know what this a is yet, but they give us enough information to find it, because if we need to know what this a value, this multiplier out front is, we can use the given function. Because basically, if we let this be our unknown a value, we can plug in a negative 6 for every x. And we know that that's got to equal this output value of negative 180. So we're just substituting in for the f of x and for each of these x's. And we're then solving for a, which we can plug back into this form. So the way that you would set up and solve for this type of equation would be to, again, use your solve feature. Type in negative 180 is equal to, I'm going to leave it as a, so a times. Remember, you have to explicitly multiply here, otherwise your calculator will show an error. And then I'm just going to enter negative 6 minus 4. Now, if I don't want to enter each of these individually, what I could do is enter the function x minus 4 times x minus 3 times x plus 5. And then at the end of this, before I tell it what I want it to solve for, or even after is fine, but I'm going to use my with key. Tell it I'm going to substitute x in for negative 6, and I want to solve for a. So comma a tells it, the calculator, what I'm solving for. And when I hit enter, I get my a value to be a 2, which I can then write up here, and that gives me the function that I was looking for.